This is homework help video for Chapter 5 for statistics. The subject of the video is bonds and insurance. For both bonds and insurance, investments in general, depending on which side of the fence you're on, you need four things. Actually, only three. Well, first you need the amount that you're going to get back if things go well. Then you need to know the amount that will be lost if things do not go well. You'll need the probability that things will not go well, and you need the probability that things will be fine. So you put those four together, and then you can compute the expected value, which is what you're looking for, the expected value. So the problems are usually posed like this. Say you have a $10,000 investment in a bond, or you're thinking about it, and so you have $10,000 to invest in a bond that has a 4% return and a 2% default rate. So now we can use that information to answer those first two questions. The amount that the investment would return to you is $400. Things go well. The amount that will be lost if the bond defaults is the entire $10,000. If it defaults, you don't get the money you put in there. So you could either get $400 back, or you could lose $10,000. What is the probability that things will not go well? Well, 2% default rate. The 2% right here, this 2%, or this 4%, I'm sorry, that has to do with how much you're going to get back. 2% default rate means there's a 2% chance that the bond will default. So there's a 2% probability that things are not going to go well. So you take that default rate, that's a probability things will not go well, and so it's 0.02. Now the probability that everything will be fine is 1 minus 0.02, which is 0.98, 98% chance everything's going to be fine. Remember that with probabilities, all the probabilities have to add to 1. Well, the probability that things will not go well and the probability that things will go well just about covers everything. So those two have to add to 1. So all you really need to do is have one of them. The next step is to write a little table with that information. So here's my probability distribution. I have a $10,000 investment, 4% return rate, 2% default rate. Okay, the amount I'm going to get back is $400. The probability of getting that back is 98%, 0.98. Alright, if it defaults, I lose $10,000. So there's a chance I'm going to lose $10,000 doing this. And that probability is 0.02 because there's a 2% default rate. So I've just put all the information from the last page into this table. Now remember what expected value is. To find an expected value for this experiment, you take each value, value 1, times the probability that it will happen. Then you take value 2, could have used x's, but I'm going to use v, times the probability that 2 will happen, and keep going, adding all those up. In this case, the first value is 400. The probability associated with it is 0.98. The second amount is minus 10,000, put that here, and it's the probability that this will happen is 2%. Always use fractions or decimals, don't use percent in these calculations, you won't get the right answer. Okay, so when you work through that, you find that the expected value is $192. Doesn't sound like much, but at least it's positive. And you could use that to compare it to another bond that maybe you were thinking of buying. Here's the same setup, but with some different numbers. Again, you've got a $10,000 investment and a 4% return. But let's say now that the default rate is 12%. So in fractions, that means the probability that it's going to default is 0.12. What's the probability, this is for default, what's the probability that it won't default? Okay, I could use a Q. It's going to be 1 minus 0.12, and that's where I get the 0.88. Remember, all these have to add up to 1, and they do. So now we have 0.88 is the probability that you'll get your $400. 0.12 is the probability that you're going to lose $10,000. Now you can compute the expected value. You take the value times its probability, and then plus, well in this case minus, next value times the probability, you find out that the expected value for this bond is almost, well, it's over $800 loss. So the other didn't look so high, but like I say, at least it was positive. Compared to this one, this is probably something you don't want to invest in. Now we're going to look at insurance risks and their expected value. That's in terms of for the insurance company. The insurance company is looking at this. That's how, from the standpoint that we're going to do the problems. So there's a life insurance policy worth $1 million. Let's say the monthly payment is $300, but they're going to pay $3,600 annually for it. Now, from the company's standpoint, either they gain $3,600 for that year, right? Because they didn't have to pay anything out. That assumes the person lives for that year. Now, what do they lose if the person dies? They have to pay the $1 million, but then they don't have to refund the payment of $3,600, and so this is what they stand to lose. Those are the two numbers we're going to use in the probability tables. Now, to calculate the risk, you need some probabilities. Like I said here, the insurance companies keep careful statistics. There's a whole field of studies, mathematicians go into it. It's called actuary, and those are people who work up these kind of risks. They figure these things out. So they would figure out the probability that, for example, say this is a 30-year-old person buying this $1 million insurance. What's the probability a 30-year-old will die in the next year? Okay, if you're 30 years old, the probability you will live to see 31 is pretty high. The probability that you die is 0.00, in this case 1014. In other words, it's about 0.1% chance that you're going to die. A 30-year-old will die. So what's the probability that they will live? It's either you die or you live. That covers all of it, so you can take the probability you die, subtract it from 1, and get the probability that you live. So that probability is shown right here. It's 0.998. Now we can write the table. The insurance company keeps the $3,600 if the person lives. So they get $3,600, and that associated probability is this 0.99%. If the person dies, they have to pay the $1 million insurance, minus the payment, which the person should have paid, or they probably cancel it. And here's a probability that that person will die. So for the expected value, you do the usual. You multiply each value by its probability and add it all up. So when we multiply 3,600 times 0.99, and then we subtract the almost $1 million multiplied by 0.001014, we find out that the expected value this is the value to the insurance company, is about $2,500. Well, again, at least it's positive. If this is acceptable to the insurance company, then they'll probably sell the policy. If it's not acceptable, they can always raise that premium, and that will give them more. That will increase the expected value. Let's do the same problem, but this time we have a $1 million policy. The annual payment is $3,600, but let's say the person, instead of being 30 years old, is 60 years old. Ooh, that's got a mistake on it. The probability of the person not living through the year at 60 is 0.16240. In other words, about 1.6% chance that a 60-year-old will die. Remember, for a 30-year-old, the probability that of death was 0.001014, something like that. Okay, both look like pretty small numbers, but this is going to make a big difference. So if the probability of death is 0.016240, so this is the probability of death. The probability of living would be 1 minus 0.016240, and that's about 98%. Okay, so now I want to find the expected value. So I take the 3,600 and multiply by its associated probability, and then I'm adding, which in this case turns out to be a subtraction of the almost $1 million times the probability that the 60-year-old will die in the next year. The result is a negative $12,000. I'm sure that's not acceptable to the insurance company, and they would probably charge a 60-year-old a lot more if they would indeed even sell them $1 million worth of insurance.